Hello, Matrix. So we're starting financial maths, and because you've just done it in core, we are not going to do a lot of the revision stuff from the AP textbook. But I would encourage you just to breeze through from the beginning of the red book until page 39, just to give you an overview of what you should know. But really, it's basic. It's really, all of that is just kind of a summary of what you've done in core since grade 10. Okay, it looks at simple interest, looks at compound interest, it looks at timelines, it looks at converting nominal to effective rates, different compounding periods, etc. And then it introduces future value and present value annuities. Okay, but I want to start on page 40 of your red book. So if you turn there now, and if you haven't got your red book with you, you can pause the video now and then restart it once you've got it. So I'm looking at example 3 and 4 on pages 40 and 41 respectively. And what I'm really looking at here are determining the amount of payments. So you've learnt in core that the amount that in a future value annuity, the standard kind of payment procedure is that each payment happens at the end of the month. So if you open your account at the beginning of January, your first payment is at the end of January, and then at the end of February, end of March, and then finally at the end of December. So there would be 12 payments over 1 year. Sometimes there's one extra payment, which is immediate payment. So in other words, that's when you've opened the account now on the 1st of January, and you pay your first installment on that same day. Okay, but then thereafter, every payment is still at the end of every month. It doesn't mean that your last payment necessarily happens at the beginning of December. Okay, so when there's an immediate payment, it's an extra payment. All right, so there's two ways of determining the amount of payments. Firstly, like I said, if it's standard, it's 12 payments a year if it's monthly. And then if there's an immediate payment, you add 1. Okay, so you would get 13 payments in a year. Now, if you look at example 3 on page 40, they have an example where payments of 2,000 Rand are paid monthly, and they end at the end of the 15th month, but there's an initial payment at T0. All right, so there are two ways of working out the amounts of payments. First of all, we know that there should be 15 payments because T1 is the first payment, T2 is the second payment, etc., in a normal situation. And then because there's that extra payment at T0, we add 1 to the 15. Another way that you can work it out is how they've done it in their solutions there, where you take the number of the last payment, so in this case 15, you subtract the number of the first payment, in this case 0, because it's at T0, so 15 minus 0, and then you add 1 to get the 16. Now, if you look at page 41, there they've got a very different type of payment scenario, where the first payment in this case is actually at T3. Now, because it's a future value, that means that at T0, when the account is opened, nothing is actually deposited. So in other words, no money there's nothing in the account. Nothing happens between T0 and T3 because there's no money in the account. So there's no interest growing or anything like that. So the number of payments here are, if you do it the first way that I explained to you, there should be a payment at T1, there isn't. There should be a payment at T2, there isn't. So there are 2 payments that have been missed. And it goes up to 25. So 25 minus those 2 payments that have been missed gives us 23. Okay, alternatively, you can take the number of the last payment, which is 25, subtract the number of the first payment, which is 3. 25 minus 3 is 22, and then you add 1 to get 23. I'm not doing those 2 examples in detail, but I'd encourage you just to look through them. It's really just what you've done in core. Right, example 5 on page 42. I want to do that with you in a slightly different way. Right, so they talk about payments of 6,000 Rand that are spaced at monthly intervals starting at T1, so that's standard, end of the first month, and ending at T18. Payments end at T18, so after 18 months. the interest rate is 18% per annum compounded monthly. Right, now if you look at the timeline goes up until 20 months. All right, and if you look at the questions, question A says calculate the future value of the annuity once the last payment has been made at T18. And then question B, calculate the future value, A, of the lump sum F after 2 months if no further payments of 6,000 Rand are made after the last payment at T18. Okay, we're going to do those two questions in one go. All right, so we're not going to worry about their variables in B, A, and F. We're just going to use F for future value. All right, so that I can show you how we can do this in one step. Look through their example and see how you do it in 2 steps. But normally in an exam, they would ask you to do this in 1 step. Okay, so using our future value formula, which is x into 1 plus I to the power of n minus 1 all over I, we can say that we know that the payments are 6,000 Rand, and we've got the interest rate of 18% compounded monthly. That'll go at the bottom as well. Right, and then the number of payments, there are 18 payments. Okay, because the first one's at T1, the last one's at T18. Okay, so this whole thing that I'm surrounding with the rectangle, the green rectangle, is what is available at the end of T18. So that would be the answer to A, the way they've asked it. But now, in question B, it says, calculate the future value after 2 months if no further payments of 6,000 are made. So, in other words, there should be a payment at T19 and there should be a payment at T20. Remember, with future value, the last payment's always right at the end of the period, unless they tell you otherwise. So, in other words, we know here that there are 2 payments that have been missed. So, all we do then is we multiply this whole green rectangle effectively becomes the principal in a compound interest formula now, because with compound interest there aren't regular payments, and from T18 to T20 there are no regular payments, and we grow that amount at the same interest rate compounded monthly for a further 2 months, and then we can put that all on the calculator in one go to get a total of 126,652 Rand. It's comma 0026, I think, so it rounds off to the nearest Rand in this case. Right, on to present value annuities, which starts on page 45. And I don't need you to worry about page 45 itself, because again, we've looked at present value annuities in core maths, and on page 46, they just give you the formula to remind you of it. And I want you just to look at example 6 briefly on page 46. That is the standard kind of example you've done in core. Okay, remember that it's in present value, there's always a payment gap. There's never ever an initial payment that you're going to incorporate into your formula, because if they do pay something immediately, then that's just taken off the present value, because it won't be part of the loan. You won't pay interest on it. Okay, so for example, if you take our loan of 100,000 Rand and you're going to pay it off in 10,000 Rand installments, and your first 10,000 Rand is immediately, then that means that your loan is 90,000, and then your first payment will still be after 1 month. Okay, so there's always a payment gap or an interval, and that's why in the questions they always say that payments start 1 month after the granting of the loan. That's just to remind you that there's that payment gap. Okay, so example 6 is straightforward, as you've done in core. But I want you to look at example 7. And that's on page 47. Okay, so it says payments of 4,000 Rand are spaced at monthly intervals, starting at T3 and ending at T12. Okay, so in other words, over a year. But the loan is granted at the beginning of the year, for argument's sake. And the first payment should be at T1, but it doesn't happen. And the second payment should be at T2, but it also doesn't happen. Okay, so the first payment actually happens at T3. All right, so we've got from T3 to T12. So again, you can work out your end value by either saying, well, there should be 12 payments over the year, but there are 2 missing, therefore the number of payments is 10. Or you can say 12 minus 3, which gives you 9, and then plus 1, which gives you 10. Okay, so in the textbook, they speak about 2 different methods of working out what the present value is. In other words, what was loaned at the beginning of the year. All right, I'm going to focus on method 2, which I think is easier, and it's what we were taught, or what we were taught, because, well, I was taught it, I suppose, but what we taught you. All right, so the key thing with the present value, remember that the first payment is after 1 month. But because there are 2 months that have been missed here, at T1 there wasn't a payment, and at T2 there wasn't a payment, we would have to, in the present value formula, we would have to grow that present value, whatever was loaned, will earn interest for 2 months, and it's going to get bigger because no payments have been made. All right, and it earns interest at the same interest rate as what was quoted for the whole loan. So in other words, it's 15% compounded monthly, so 0.15 divided by 12, and that's to the power of 2 because 2 payments were missed. That is equal to the payments, the size of the payment that is made, so 4,000, and that is into 1 minus 1 plus 0.15 over 12, and this is to the power of negative 10, which we worked out. Okay, don't get confused with the negatives when you're working out number of payments. All right, you work out the number of payments, and then you just remember, because it's present value, it's got to be negative. So there are 10 payments, therefore it's going to be negative 10. Okay, over 0.15 over 12. Okay, so all you would need to do now is put the entire right-hand side of the equation into your calculator, and then divide by the bracket that is being multiplied to the P on the left-hand side to get a total of 36,464 Rand and 79 cents. Okay, so that gives you a brief overview of present value and future value annuities, and just a little bit of the kind of changes that we make in AP, right? And particularly when it comes to annuities, the difference between AP and core is that there are differences in payments. There's bigger payment gaps at the beginning of a present value annuity, which is effectively called a deferred payment. And that's often that happens often in real life when you buy a new car and they say, buy the car now on the 1st of July, but only pay in October for the first time. All right, but that loan accrues interest in those few months that you think you're not paying anything. Okay, and then like you saw with the future value, payments stop at a certain time and the money stays in the account and accrues interest for an extra period of time. Okay, so your exercise, 2 exercises that I want you to do please today are exercise 2 on page 43, A and B, and exercise 3 on page 49, A to C. Right, thank you, and use the rest of the time in the lesson to do that, and if you don't finish it, please complete it at home, but it shouldn't take you long. There are only 5 questions in total.